Okay guys, so today we're going to take a look at our next assessment in STEM, assessment item number 2, which is a multimodal research investigation. It is a summative assessment. You'll have 90 days and we're looking at these following criteria: research and planning, analysis of evidence, interpretation and evaluation, as well as communication, and this will be due in week 8. So this is our summative internal assessment 2, IA2, and it's a research investigation worth 48% of your total grade. The assessment instrument is used to determine student achievement in the following objectives: apply an understanding of drone science and technology to modify experimental design and process primary data. Number 2, analyze experimental evidence collected using drones. Number 3, interpret experimental evidence. Number 4, investigate phenomenon associated with drone science and technology through an experiment. Number 5, evaluate experimental processes and draw conclusions about drone science and technology. And number 6, communicate these understandings and experimental findings, arguments and conclusions regarding drone science and technology. So the subject is STEM. It is assessment number 2. It is a student experiment and we're looking at drone science and drone technology. You'll have 30 hours of class time and you'll be providing a multimodal response. Basically, it means that you won't be bound by a report format and you'll be able to choose however you want to present this information. For example, if you were to write a report or perhaps make a poster, the length would be around 800 to 1200 words in order to cover all of the criteria. However, if you chose to present your findings in the form of a podcast, a movie, or a song maybe, you might need around 12 to 15 minutes of content. So you'll be working in your research groups, however you will be getting an individual grade, just like the previous assessments. And you'll have resources available to you on Student Cafe and the library. To complete this task, you must do the following: identify a variable to investigate, develop a research question to be investigated, research relevant background, scientific information to inform the research question and methodology, conduct a risk assessment and account for risks in the methodology, conduct the experiment, collect sufficient and relevant qualitative and/or quantitative data to address the research question, process and present the data appropriately, analyze the evidence to identify trends, patterns and relationships, analyze the evidence to identify certain uncertainties and limitations, interpret the evidence to draw conclusions to the research question, evaluate the reliability and validity of the experimental process, suggest possible improvements and extensions to the experiment, and communicate the findings in an appropriate scientific genre. In Term 1, Week 7, you will be required to select the variable that you want to investigate and propose your experimental design. In Term 1, Week 8, you'll start conducting your experiment and processing the data. By Term 2 in Week 3, you will begin analysing and evaluating the evidence. By Week 5 in Term 2, you will submit a draft, and in Week 8 you will submit your final response. Each of the criteria are worth equal marks, so each one is marked out of 12. As mentioned before, the response must be presented using an appropriate scientific genre. In this case, you can choose any format you like to present the information that you found during your research. But it's important that you still contain the scientific elements that are consistent across all areas of science. And these include having a research question, a rationale for the experiment, reference to the variable being investigated and the experimental design and methodology, having some raw and processed qualitative or quantitative data, analysing the evidence, drawing conclusions based on the evidence, evaluating the methodology and suggesting improvements and extensions for further experiments, and referencing all the sources that you've used. Here's an example of something that you could do. You may want to conduct an experiment to determine how the number of cells in a lithium polymer or LiPo battery affects the top speed of a drone. Your research question might be, what is the relationship between the supplied voltage of a lithium polymer battery and the maximum velocity of a drone from a consistent height above the ground for a given distance and using constant components? So the steps involved will be first to identify the independent variable that you are going to investigate, which in this case is the number of cells in a lithium polymer battery. Then you need to identify the dependent variable, in this case the horizontal velocity. Identify the methodology that you will use. So for example, a drone will be flown horizontally from a starting point. The motion of the drone will be video recorded. The horizontal velocity will be determined using a smartphone app designed to measure displacement and velocity, etc. Your draft research question might be, what is the relationship between the number of cells in a battery and the velocity of a drone? And your more refined research question would be, what is the relationship between battery voltage and motor RPM that affects the velocity of a drone flown from a constant height above the ground for a given distance and using constant components? This example you cannot use in your own research question for your experiment. You'll have to come up with your own. The way this is going to be marked is through using an instrument-specific marking guide, or ISMG. And the first criteria is researching and planning. So this will assess how you apply an understanding of drone science and technology to design your experiment and process primary data, as well as investigate phenomena associated with drone science and technology through an experiment. If your multimodal response is an informed application of your understanding of drone science and technology to design an experiment with methodologies demonstrated by a considered rationale for the experiment, as well as an effective and efficient investigation of drone science and technology demonstrated by a specific and relevant research question, a considered methodology that enables the collection of sufficient and relevant data, and you've considered the risks and ethical or environmental issues, then you'll get a grade within 9 to 12 marks. So according to this criteria, you'll be marked on how well you do this particular objective, either getting 9 to 12 marks, 5 to 8 marks, 1 to 4 marks, or 0 marks if you do not satisfy any of the descriptors above. Moving on to the next criteria, a good response would include the following: an appropriate application of algorithms, visual and graphical representations of data about drone science and technology demonstrated by correct and relevant processings of data, a systematic and effective analysis of experimental evidence demonstrated by thorough identification of relevant trends, patterns, or relationships, thorough and appropriate identification of the uncertainty and limitations of the evidence, effective and efficient investigation of drone science technology demonstrated by the collection of sufficient and relevant raw data. Consequently, you'll be graded on how well you fit these descriptions. The third criteria is the interpretation and evaluation of your results. In order to get the top mark for this category, you need to provide insightful interpretation of experimental evidence about drone science and technology demonstrated by justified conclusions and linked to the research question, as well as providing a critical evaluation of experimental processes about drone science and technology demonstrated by a justified discussion of the reliability and validity of the experimental process, as well as suggested improvements and extensions to the experiment which are logically derived from the analysis of the evidence. So in this category, between 9 and 12 marks, the middle category 5 to 8, and if you do not meet any of the above descriptors, you'll get 0. Lastly, communication will be assessed on how well you communicate the understandings and experimental findings, arguments and conclusions about drone science and technology. And like I said before, you can do this in multiple different ways, using multiple different formats. So in order to get the top mark, you need to provide an effective communication of understandings and experimental findings, arguments and conclusions about drone science and technology, demonstrated by a fluent and concise use of language, including scientific terminology and representations, advanced use of genre conventions, whichever genre you choose to use, and acknowledgement of sources of information through the appropriate use of referencing conventions. If you provide an adequate use of communication and understandings in your argument, competent use of language, appropriate genre conventions, and basic referencing conventions, you'll receive a mark between 5 to 8. If your communication is rudimentary, inconsistent, and uses references or no references, you will only get a grade between 1 and 4, and if you do not satisfy any of the descriptors above, you'll get a grade of 0. And that's the entire task. If we go back to the top, you can see that all of the criteria are weighted equally. And so communication, evaluation, researching and planning, analysis of evidence are all worth equal mark. And you can choose any type of format you want to try and meet those criteria. The reason we're using instrument-specific marking guides in this assessment is to help prepare you for senior science in Year 11 and 12. If you have any questions, please feel free to ask.